Yeah, the one that you need to download, yeah, this. Come on, my mouse. Okay, here. Yeah. The address for that is SQLite browser. SQLite browser.org. Like this, SQLitebrowser.org. Then Windows version, Mac version. If you have a server, then you can download the server version as well. This provides graphical user interface for database user. It's not command line based database access, which we will do probably next week. Okay. Okay. Before we do, we'll, you know, when will be our final exam, right? When is our final exam? 21st, the 2nd, and 3rd. If you miss the 3rd one, then you miss the semester because 23rd is the last day. But I'm thinking of the 23rd. I think I put there evening, right? So I'm thinking of bringing it back to the morning, Friday morning. Anyway, Friday morning is our session here. Would it be good rather than Friday evening? Probably like.
Yeah, I'm on the. Maybe I need the L4 now at Chinese 3. Yeah.
So you will take it earlier, right? Anyway.
I will take it before 23, so.
Right.
I
Are you going back to your country?
Yeah.
For winter?
Yeah.
Oh, you're rich.
No, my parents just want, have a Chinese New Year.
When is the Chinese New Year? It's not Chinese. It's not
Yeah,
Chinese
just
New Year, right?
when I come back as Chinese New Year, or I say they just want to
Just New Year.
just New Year.
Right. Chinese New Year is according to the lunar calendar. So the New Year, I do not know when, but it's not the same as February. So are you going back to your country in February too?
No.
Because you cannot make, you make
come
this
back
time.
and then to
Okay.
stay with them.
So let's try to fix if it is the case. Or I can give you one more session. Friday morning and Friday evening. So those who, so that for example, I can take a look Friday morning. If everybody took, then I don't need to open for Friday evening. So let's try.
So, Professor, the exam, is it going to be only programming, or will there be questions like objectives and short answers?
This time, we don't do much programming, right?
Okay.
So operating systems, network operating systems, and database today. So more questions from
From the slides.
the material covered after the midterm, which is a little bit of programming is only to test some concepts using Python in a way that you do not forget Python, and also in a way that Python is so powerful to do something about this field, for example, network or operating system, and in this case, database. So I want you to somehow understand the expandability of the Python That is the reason that I covered Python, but mainly the other topics that we covered after midterm is simply those are the subject from basic computer science, core computer science majors.
So what do we, for SQLite, we get the pre-compiled binaries for Windows? Like when you go to download?
Oh, the first one?
It says like a .dll. Is that what it's supposed to be?
No. I'll get back to that. Let me do this first.
Which one did you get?
Yeah, I downloaded EXE.
No, this one, the SQLite.
No, he wants us to download DB browser.
Yeah, this one I got.
Yeah.
Oh, you're not SQLite.
Not as good. Yeah, that's right.
Okay, here.
So we're going to have 2 more classes.
No, one more class.
More. Oh, so you're not going to...
And then final exam. Okay, here, yeah, Friday afternoon. But I'm going to here's what I want to do. Wow. Why? Okay. All right. So there's option and an extra. Extra is Friday 23rd. Option 3 is 8:30 a.m., which is the class, regular class here. 8:30 to
You won't be here, right?
no 11:30, 8:30, 9:30, 10:30, 11:30. Yeah.
That's to 11:30 p.m.
Thank you. A.m. Okay, so that I can submit the change. Okay. I think this is better. So those who can take your final exam at the time that we meet, you can also take it. Hopefully you can finish it before the extra. Okay? So extra, I think this is the last moment of this semester. Probably this semester will end 5 o'clock or 6 o'clock, 5 p.m. or 6 p.m. So this is outside. That's what I meant. This is my mistake, yeah. So hopefully you can take all at least one of those 3 options, but still possible this extra. Hopefully the Blackboard is still open. All right, this is the final exam. And back to SQLite engine. Which one did you click? Download. Okay, here I want you to download the pre-compiled.
You see what's SQLite?
Oh,
Yeah, pre-compiled binary for Windows.
Windows, and then it just gives me a .dll.
No, no, I think it is. I'm not sure what it gives you.
SQL 64-bit DLL.
Oh yeah, it is DL. Yeah. This is it. Universal. What is the other?
How do you open it? Like, do you unzip it and then open it?
No, when you install it, after that the command line.
Oh, okay.
Then you have to do SQLite, and it is not GUI.
Oh, okay.
Okay. That is the reason I ask you to download this GUI-based, the browser. We're going to start with the easiest one, which is the graphical user interface. And then next week class, a little bit of a command line, and also a little bit about the most powerful way of using host language to access back-end process, whatever that is. For example, if it is a database, then we use database command. Within host language, we assume that host language in our case is Python. So using Python, executing SQL language in the back-end database engine. Okay, that is the utmost goal. Another layer that you can maximize the way of accessing is that you can implement that on your smartphone, for example. So you can build the smartphone apps, and from there you can provide some of the buttons and text box, so user enters some of those, and then all the SQL statements will be submitted from your smartphone apps to the web server, which is running behind the remote and wireless communication. We don't do that here in this class. Okay.
Does the web server, you ever heard of the web server, does that have SQLite? Like, can you access SQLite through the web server?
Web server is a web. Web server may be able to connect database behind. Then one of the databases, maybe SQLite, as it says, SQLite is a light version.
No, WAMP server.
A WAMP, same thing.
No, WAMP. The one that
yeah, WAMP or
PHP and MySQL.
Right, same thing.
Okay.
It's not WAMP is for Windows version, which is not really ideal. When I taught 359, we use LAMP. So Linux, not Windows. Okay. All of our servers also Linux version. Few faculty use Windows also.
Yeah. We were able to sign on to the other class through like the VPN.
Oh yeah.
Yeah, we were able to we were given each an account.
Mm-hmm. Okay, so that's clear.
Is it checkpoint secure remote?
Yeah, that is the one. Let me help you recall the first concept that we learned last time. Database schema definition is very, very important. What is database schema? Database schema is nothing but a set of relation schemas. Then someone may ask you, what is a relation schema? Relation schema is a set of attributes. Relation schema, that is relation schema. So example of a relation schema for college database is on that slide. For example, the first relation schema, so first relation is a student. Another relation, department. Another relation, faculty and class. The idea here is that students who is in a particular department, that is a major department, involved in multiple classes. Each class is taught by faculty member, and that faculty is again in particular department. That is the relationships among relations. Okay. So there's the way that I described so far is linked there. Students So student CWID is like this, is taking a class, right, like this, and that class is taught by a faculty member, although with different name, fac. It doesn't matter, that is your variable, right? User does not know. User does know only the way that you express in the outcome. This is internal definition of database. So, but database designers should know. For example, faculty can be defined over two attributes: faculty name and department where that faculty is associated or affiliated. Then faculty name also appear in class relation, class table as an instructor. So name, a particular value for faculty name should appear here, instructor or fac name in the class table. Same thing. In the class table, there are a list of students. Those students is nothing but CWID in the student table. In the student table, there is an attribute called the major. So students can major some subjects. This major is nothing but the department name. Okay? So we have another linkages here. Major is nothing but department name.
These are all int or text?
Text. Yeah. That's a type. So attribute followed by type, comma, another attribute followed by comma, attribute type, comma, attribute type, comma. This is a real language. Most database languages take that. This is a standard. Again, department table is defined over department name and the chair's name. And this department name is used in the student table as a student major, and also department name is used in the faculty table as their affiliation. That makes sense, right? That is a real world story, scenario. So initially, how can we design that story in a table or set of tables in a computer? That is the idea started in early 1960s. And yeah, so we'll look at following slides. Some short Asian guy try to think, oh, is there any possible way that we can describe that more nicely? Nothing in text, but some drawing, and whoever comes and look at and interpret that drawings, that remains the same to other people. So that is somehow common, the interface, and everybody can understand equally the same, and that is good tool to communicate, to make sure that there are requirements, and based upon that, the final version of database implementation will be also consistent. Okay. I'm not sure he's still alive. His name is Peter Chan. When he was in Harvard, he was in math department in 1960s, Harvard University. And his PhD thesis was that entity relationship model. And he taught many universities, and then finally, after he retired, and then he came back to Louisiana State University 30 years ago. 30 years ago. 20 years ago. Yeah, 30 years ago. And stayed there. Last time when I saw him was about 18 years ago. No. About 11, 12 years ago. It was a short time. Okay. From this slide, lots of other definition. What is a DBMS? So you should understand. DBMS means is a collection of database management software packages. When you say DBMS, that's software packages. What are the DBMS that you know? For example, Access. Don't call it database. DBMS is right. That's no, it is, but it's a toy. No one say that is DBMS. Should be a little bit above that.
PHP? No.
PHP is a language. That's a web language.
Oh, okay.
I think if you are talking about WAMP, then MySQL. That is very good DBMS. Another, this SQLite, it's kind of a DBMS, but if you look at the engine, that is not really DBMS. It emulates some of the simple way of database engine.
SQL Server?
SQL Server, definitely, that is a DBMS running on Windows systems developed by Microsoft database group.
Oracle?
Oracle, definitely. Oracle is very good. And yeah, that is the powerful and widely used DBMS. Another old DBMS is called the DB2, that is IBM products, not widely used, but all the banking systems still rely on DB2. And some of the languages, SQLite, the SQL language, that is developed by IBM Research Center at Almaden, which is West Coast. West Coast IBM is software-related research lab. Watson here is other than software, all kinds. Okay, mechanical engineering, material science, hardware, everything. There, one scientist, he doesn't have a PhD. He doesn't have a master's degree. He joined IBM Almaden Center as a bachelor degree. His name is C.J. Gate. He developed a SQL language, and he has been invited by many universities, for example, Stanford universities. Hey, come and become our faculty member. He doesn't. Oh no, I don't want to. I don't have any degree. I don't want to. But he's famous. He's top one database researcher. Back till 20 or 30 years ago, right? Database technology now is stabilized. Not much research. Now research comes some other areas. But anyway, that is the DBMS. So the most powerful DBMS right now is Oracle. So Oracle is the company holds MySQL also. MySQL is owned by Oracle. It's not developed by Oracle. It was developed by Sun Microsystems, which develops Sun workstation, Sun servers, Solaris, all powerful computing powers till 10 years ago. And then that company didn't run the company well, although they produced the top products. But marketing is not really good, therefore acquired by Oracle. So now Oracle has, not only that, Java, right? Java programming languages also developed by Sun Microsystems. So now it is all owned by Oracle. So Java compiler is distributed by Oracle for free. That was the agreement, the acquirement agreement. Sun Microsystems distributed all free, MySQL free, Java free,
Oracle
everything free, while Microsoft sells everything. Whatever Microsoft has, they sell. But Sun Microsystems, they don't sell, they distribute it free, but they sell only the hardware. Question?
Oh, Oracle acquired Sun.
Mm-hmm.
Sun Microsystems. Oh, okay. Who created Python?
Oh, Python created by one guy, I think in Netherlands. Around this time. about 20 years ago. That guy is so brilliant. He was, yeah, in 2 weeks. He was in Switzerland. In Switzerland, there is a physics lab, right? Some very famous, world famous physics lab. He was working for the physics lab, and one Christmas break, and he was bored. My Christmas break, not really boring. Sleeping is also so good. But I don't know why. He's a brightest guy. He thought, so bored. Okay, let's create one language. That's the language they created, Python. That is the reason Python is not really formally invented the language. Therefore, there's no foundation. And everybody add some good things into that small core Python. Everyone wants to add. It became bigger and bigger and bigger till Python 2.7. And around that time, wait a minute. Formal programming language specialists said, oh, wait a minute. Python is not the language we will neglect in the future. Maybe one of the powerful language. Then, before too late, let's make some foundation. So from here, we can develop. We will have the same stream of Python development, but at some points we need to freeze all the development at this point, and let's take all good things to start from strong foundations. That is Python 3.0. Okay, so now Python 3.6, 6? Yeah, 6 is the one that, 6, when I downloaded it, it was beta version. I'm not sure, still beta version. Or maybe 7 now. Okay, that is DBMS. DBS. This is also.
Will there be another programming language soon? Like besides Swift is new, right?
Swift is like Swift language, which is developed by Apple, which is a good language. So we'll use it in the spring course 555 to develop iPhone apps. Those who knows Python can pick up Swift very quickly, and the outcome is great amusement and excitement if it runs on your iPhone. Okay, those who have Mac OS, highly welcome. Those who do not have Mac, then you need to run Mac OS over virtual machine. That is also possible.
Will it be offered in the fall? Like, or the
No, only in the spring semester.
Oh, that's right. Okay. I see.
Okay. So what is DBS? DBS, so-called database system. Database system is a database running on a DBMS. So we know what DBMS is, right? That is the software packages. Yet we do not know what is DB. Okay, then what is DB? DB is a collection of data. Database, so-called database. Database is just a collection of data. Has nothing to do with specific software packages. Any collection of data is called a database. That's what we use, right? But don't be confused. When you say database system, if you add system to database, then that is the terminologies that we have a specific database, specific DBMS, and some implementation done. Okay, this is the database system. Okay, So if somebody says to you, we have database systems, can you join us developing something? Then if you need to be smart. Okay. So what is the DBMS running for your database system? Then you can say, oh, our DBMS is Oracle, then you can speak more about Oracle. Okay. Another terminology here, relation. What is a relation? Relation is nothing but a table, as we spoken many times. Relational database. That is relational database. That is also very, very important terminologies. Relational database. Anybody heard other terminologies, other databases, so-called, other than relational database? Anybody heard any other databases but relational? Probably not, right? You're not studying database much. Okay.
Class on that. We took a class on that.
Right. Previously, we had network database, hierarchical database, functional database,
Relational.
and then relational database came up. But real fundamental theoretical database is a functional database. Okay. And after that, IBM Almaden Center developed the relational database, first formal DBMS, DB2. Therefore, after that, relational database became popular and popular. It was around 1980, and then over 35 years, right? So now very, very popular. Other than a relational database, still few other databases developed, which is called object-oriented database and deductive databases. So when I studied for my PhD degree, I studied the deductive databases. What it means is that databases should be intelligent. Can database deduce something new from everything known? Right? That's a deductive database. Some of the deductive database has been implemented and currently widely used. That is active deductive database. Active. So whatever deduced from database, we can take on action in response to whatever event that is active database. One of the feature that you may take advantages and benefits from is alerter or notification. Something changes, then there's a notification, right, to your iPhone. You enjoy that, right? For example, credit card. You charge a credit card at the store, $25. 1 minute later, we have a notification here. It changes the database of credit card companies, and when it is updated, then if there is a setting, alerter or notification, you need to set, right? If any transactions over $10, then notification should be made to my cell phone number, so they can put the 914, then immediately you will know, right? Which is so handy. Right, Afolabi? Do you have a credit card? Do you use a credit card of your mother, father? Something like that, right? I lend my credit card, not mine, my wife's credit card to my son. But intended, so that I know where he is. He used the credit card. Many times the Uber, Uber, 2 o'clock in the morning. This guy went to some other place. So all the money related to transactions is notified here. So I know how he is. Which is good, right? That is active database. Active data.
I have a question. These deductive databases you speak of, they conclude additional facts. What kind of facts do they conclude?
There is a reasoning tool, like artificial intelligence. So, for example, in college database course, one course has a prerequisite. The prerequisite course prerequisite on another and another and another. In the database, only there is this course requires one course. If we go to that course requires another, that course requires another, that course requires another and another. So when you take a course, you may be able to see, if I take this successfully, then I can expect a lot more courses to be successful, because I take this course, and because this course is required, not directly but indirectly, from many other courses, so that you can tell, this course is the most important course. So if I study this very well, then I can succeed 50% of my career. That type of things is deductive.
You may continue. Sorry.
Okay. Another one is key. So you need to understand the two types of keys, primary and foreign key. Keys is nothing but a set of attributes, keys, that can determine a record. In other words, that key is the attribute that can discriminate one record from the rest. So that's unique. That makes a record unique. For example, student. If you look at the student table, and we have multiple attributes available, right? CWID, age, major. So which attribute makes every single records on that table, student table, unique? CWID. So that is the key. That is the key. We call that primary key. While we have primary key, we have also another terminology called foreign key. Foreign key. If you look at here, major. Okay, here major. Major is not a key in the student table, right? Clearly, it is not a key. Major is not a key. But see, I linked here. Major is a department name in the department table, right? I wanted to look at these two tables. Okay, in the department table, department name is the key, right? There is no two departments having the same department name. Therefore, if we know department name, then we know where that department is and who is the chairperson and what they which courses they deliver, and everything determined by department name. This is the key here, right? So we call that PK, primary key. But exact same value may appear in another table as different name, not necessarily different name, it could be the same name, Well, we call that student major. Right? So somehow they need to be related. They need to be related. What kind of a relationships needed between student major and department name? We call that foreign key. What kind of a relationships? I mean, in real scenario. Real scenario is this: student cannot take major which is not available. That's true, right?
Yeah.
What does that mean? Before student major exists, the department should exist first, right? So existence are dependencies. So which one dependent what? Dependent what? Student major dependent on department name. Not only that, if department name is deleted, what happens? Then student major is no longer available. That is true, right? So in real database, what happens? If somebody accidentally delete department name, that affects so many students. So your database should let you know if you say delete department name. Then wait. Are you sure to delete all the majors of such students? We have 500 students majoring your department. Are you going to delete their major also? Yes or no? Click no. Right? That type of things needs to be done. That is an active database, right? Previously, there is no such consistency management tools available in DBMS. Okay. Somehow, why we call this foreign key? Major here, major of student table is not the same as age. For example, student age, there is a value standalone for students only. There's no other related connection at all. Age is age. That's it. That's a standalone. But major, existence, deletion, updates, all related with somewhere, right? Which is the department. And when you go that department, the same value here doesn't determine students, but the major name here doesn't determine students. However, the same value of a major here in the department determines the department table. So the same value here is primary key. However, the same value in another department is not a key. Of course, this is primary key there, right? Therefore, this is not a key, major, but it is not the arbitrary other attribute either. We have to treat it a little different, right? So we call that foreign key. What does that mean here is that I didn't bring that. Sorry. I know your name, but just forgot. Hammer. Hammer was a queen in Nigeria. So she's a real queen. She's working for the UN representative of Nigeria. So she's a queen. She determines Nigeria, when she go back. Everybody here, right? Or, oh yeah. You look pretty sad.
Sure.
Yeah. If I go back, my home country, I'm one of the slaves, so. So, Queen, so primary key in Nigeria. But in America, she's same as others. But is she really the same as others? No, it's really different, right? She's not only here. Identity of her is currently here, but her identity also in Nigeria. If Nigeria deletes her identity, then her identity in America is meaningless, no longer exists. That type of things. So we call her foreign key, right? So you also foreign key. There is also, another one, foreign slave. There is no such things. Okay, so we have a primary key and foreign key. Okay, so you understand, right? So that is very, very important in a relational database. If you do not have foreign key definition, then accidentally, what happens? Some students here at Mercy and studying some major, but there's no department. That's possible. Maybe archaeology once. You're going to study something new, which nobody has been trying here at Mercy. So you are the first one majoring. What is it? Do you have any? Okay. Develop. So you will be the king. Okay, so all the terminology here on the first slide is very, very important. If you understand this, then you understood 50% of database technologies. All others, just minor details. Okay. Start with this database construction. So I put there, right? Student, CWID, enroll, and course. Okay. Previously, I have student and class, then I link them directly, right? Student here and faculty there. But in another, so for the same application domain, we may have multiple different ways of implementation. This is another way of implementation. Students takes a class. Actually, this is a class, right? We call that class. This is course. What is the difference course and class? Course is formal, appears on your catalog. Class is real implementation, right? So course can be offered in spring 2017, then we call that a class. Okay? Course, that is available in catalog. Not all the courses offered every semester. A few, right? So different implementation at each semester. But anyway, so we have a student and course in general. Course appears in catalogs, so there's a course title and credits, and students separately from the course, we have a student database, as we looked at before. And then there is some enrollment. Okay, each semester we have some enrollment tables so that you can register. So as you register, then you have student ID comes, your student ID. When you click, for example, one course, 505, then your ID comes in here. And then, because you select one of the course, that course here, together will be a one record. There's a one transaction is created in a database. So next time when you come, if you enter your student ID, then your database, search through all enrollmental transactions, and then display the course list already chosen, right? So that you can see. So among those, you may remove to drop, you may change it, you may add more. So this is a new table to be considered. In this way, the registration can be manipulated very, very efficiently, right? While you keep students table and course table separately, still you can manage it, the enrollment. So let's take a look at SQL. SQL language, so many issues. Using SQL that you can define data. Okay. In order to build a database system, now you know the terminology, right? Okay, let's try to build a database system. Then what you need to do? Because it is database system, you need to have data sets, you need to have DBMS, right? If you have a very big data sets, and also the consistency of data is the most important, then you need to buy expensive DBMS like Oracle. Although you have a very big data, consistency is not really important, but whatever outcome from that big data is important to you. Not each individual transaction, but some analytic outcome is important, then you can do something else, right? Something else that doesn't do much about consistency management. That is possible. Another thing that your SQL can do for you is basic query structure. Very basic, and that can describe what you want from your database. That is possible. So additional operations. SQL language is declarative language. Declarative language, which means non-procedural language. There is no procedure. Therefore, it is easy to express what you want. You don't need to worry about how you can get the result from your data. Simply you can describe, hey, this is what I want. All the details of procedures can be handled by another DBMS software package. That is query optimizer, logical optimizer, physical optimizer. There's all kinds of optimizer software packages available. You rely on them. But if you want to manipulate the procedure on your own, or if you want to make more powerful query statements, then you need a procedural language together with declarative. Typical simple SQL language. In addition to simple SQL language, you need to have some procedural components to be added. For example, Oracle therefore has a PL SQL. PL stands for procedural language. Okay. And many other even simple DBMS can be interoperable with the host language, so that you can use SQL language from your Python project, or Java, or C. Okay? So in this class we use Python to use SQL and get and process in databases. In another, for example, in Spring we use Swift, which is next generation of C language to develop iPhone apps which can access the
Oh, Swift is next generation C, you said?
the current generation.
Oh, current generation.
Yeah.
And you're saying so, data definition, you said you need a database management system, and then depending on the size,
Depending upon the data characteristics,
Yeah.
then you have to define the real data structure, which is a container. You need to build a container, and therefore you can contain the data that you want to populate. You need to make a bunch of containers, and each container may relate to the other. Container called in this case a table, right? We would create multiple tables, like a student table, department table, enrollment table, course table, faculty table. SQL language is also a very powerful, another sense, language because it is based upon, it is built based upon set theory. Everything can be handled by set. So what is set?
very mad, set theory, I don't know.
Set. Oh, simple. Set. What is a set? What is it? What is a set in your mind? Collection of
related.
collection of same type of data, right? Yeah. Collection of same types of data. If it's a person's name and okay, that is called the tuple. If you have a name, age, major, address, phone number, we call that tuple. Tuple, the language used in database, and also the exact same term used in Python, right? In Python database is called tuple. That is exact same terminology, same definition. Set in Python is nothing but list. So set is a list in Python. Set in database is a list in Python, which is a collection of same type of data. Same type. If it is a college name, then all college names. Mercy, Iona, Harvard, MIT, all good ones. Okay. That is set. But in database, according to precise definition in mathematics, for example, but I don't know if there's a term available in mathematics, but in database there is a term. While we are saying set in database and set in mathematics, there's no duplication, right? No duplication. If you have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, then the set is 1, 2, 3, 4. That's a set. Is there any way that you hold them all? And very similar type as a set. That is called bag. Bag. The concept is very simple. In a bag, you can contain any duplicates, right? If you have $500, then you put 500 bills in it, right? If you put $500 bills in your set, then when you get back home, open it, and you have only one. Because they are all duplicated, all animated, only one. That is set, which is not, right? Therefore, we don't call this set, but bag. One? This is a bit funny, right? That is that is the case. Okay, so set operation and null value. Null value is very, very important in SQL description expression. Null expression is really useful when you describe anything in SQL, because it is talking about, it is based upon set, right? I can compare two sets, or I can compare one element against another set. When I compare two sets, one empty, another full bag, therefore I may have a meaningful answer. For example, enrollment. By looking at the enrollment table, then we know who registers what course, right? Is there any way that you can get list of all the students who do not register? Look at that table. Our current database table has student enrollment and course. Okay? So all the transactions, all the records of those three tables, all the records exist, right?
Yeah.
But when I ask you, list all the students who do not register, therefore, you cannot find it directly from your database, right? You do not have any such tables who do not, right? Only the table that you have here is who registered, but it doesn't have who does not register. How can you find out?
Then you find that students that are in the department or in the school that didn't register for that course in that department.
Right, in mathematics. So what you can do here is that enroll, if you project student only, not the course, student only, and then you can say, hey, this is not a bag, but set. Then all you register the 3 courses, you register 5 courses and 6 or whatever. So if you say set, then we have a list of students who currently register, right? No duplication. Okay. And student table, you eliminate all others but CWID. You have a list of students. You have a list of students who register. What is the list of students who do not register? You subtract. Right?
So you compare.
So actually, the theory behind is that there's an emptiness, right? Nullness. Null, empty, can be manipulated, can be derived from something which is. That's the only thing that we can do from our database. Right? Our database contains something existing. It doesn't have something not existing. But we can manipulate it. We can derive it based upon something that we have. Right?
We look for the empty space, the null space.
We don't do that.
We don't look for the
Yeah.
space.
That may be silly. So in database we don't do that, but we can still generate. Right? Then we can generate.
The 2 lists you have to get the null list. And see that people, students are doing.
The problem with null, null is available value, but null value mislead a lot. Number one, there are 3 types of null in database. It is null. Null may be empty or Empty, therefore, empty means, how do you interpret if somebody say, I don't know, then how do you interpret? He may not really know, right? Or he doesn't want to tell you, right? I don't know. There's so many meanings behind I don't know. Similarly, null value in database, so many meanings, but actually 3 meanings. Null itself is a real value. Null. For example, married. You say null. That's real value, right? Income, null. It's not real value. If you say income null, then not available yet, therefore null. Or some other meanings, right?
Doesn't want to tell you.
Doesn't want to tell you. Yeah, like a strong, rich guy whose name is T, right? Same thing. Aggregate functions, all other functions possible in here. Types used in SQL. It's not really standardized, but many cases that they use this. So depending upon DBMS, sometimes it allows, but not all the time. So depending upon that, you can use it. Okay, this is data. Table definition. This is a standard, so we need to use this. Create whatever you have here. Boldface is the reserved word, so create table. And also most DBMS systems is not case sensitive. It's not. So if you put your name all cap, all lowercase, whatever combination, they're all treated as one. It doesn't care base database, which means when you do your create table, you can type any combination of the cases. Okay, create table followed by table name, open parenthesis, and close parenthesis. So this is open, and this is close parenthesis. Okay. Within parentheses, you can have attribute and data type, pair, and then comma. At some pair, you may add integrity constraints. So one of the constraints is primary key, for example. Another type of constraints is foreign key. So you can add more and more. Example for that, here. We can create table, example, create table instructor, open parenthesis, ID is the instructor's ID, character of 5, so ID is 5 characters, name, there's attribute, is a varchar. Varchar means the size of character, that is in character, but size is a variable. So variable character. If it is a variable character, then if it's a fixed character, for example, simply char, then in real space utilization, if it is a 5 character only, like this, then 1, 2, 3, 4, and 5. So if you have, for example, John that okay, 5, and another 5. Smith, S M I T H, and keep going, because it knows it reads every 5 and every 5. There's no delimiter needed, but if anything, for example, here K, co, then still you need to have empty space to fill up to 5 characters and keep going.
First, when you said it reads every 5.
Yeah, in this case.
But John is 4. So it leaves
Yeah,
space.
still you need to have, yeah, whatever left, you have to left empty, because this is a fixed size,
What if
5.
the word is more than 5?
Then truncate. Yeah, it's not fitting here, 5. If it's a voucher,
I'm saying, does it like break the word up if it's more
No.
than 5?
only 5, fixed. There's a fixed
Oh,
size, yeah, fixed size. On the other hand, the variable char, var char, is a variable size, so it is really variable. So if you have a co, although it is 20, co, and every time at the end there is some delimiter, let's say backslash O. Okay? So your database pointer can understand when it comes to this special character, then they understand, oh, this is the end. So in this case, only 2 characters for name. And then it reads, oh, this is a new name, starts from here. So it can go, for example, another 20 or 25. When it reaches that delimiter, then that is the end of that once. Okay? That is a varchar. There's a pros and cons in that implementation, but another thing, today's the class will ends 11 o'clock because I need to go to another room. So I wanted to study on your own 30 minutes and then go home. Question? Clear? Another constraints, you can put not null. For example, name not null. If you add this, see here, name type followed by constraints, you may do so, not null, like not null. Which means any instructors, any records about instructors cannot be included if there is no instructor name. It is okay, no instructor ID for the moment. That is realistic, right? Sometimes, oh, we have a new adjunct. He doesn't have yet his ID, but we know his name, so we can put his name first. And then later we can add ID. In that case, we need to say not null. Okay? Another constraint here is primary key. Primary key ID. ID is a primary key, then you can say primary key, open and ID, close parentheses. In another language, probably in our case also, ID is, if it is the primary key, then right after the type of that ID, we can say primary key. That is possible. However, foreign key, usually foreign key will be a separate line. So start with the foreign space key, and this is the department name of current here. So department name is a foreign key, but which is in the department, usually reference and then table name department. Table name and open and close parentheses, you can put here department name in the instructor table, reference say name in the department table, simply name. That is also possible, right? If you eliminate the attribute name, then you assume this DEPT underscore name appears in both places, exact same name, but usually it is not the exact same name. So instead of DEPT, you may say that. So there is multiple examples of those. Tables can be created, tables can be dropped and alter and delete any row. Drop means this is entire table is dropped, and we have a drop. Delete is a few tuples, few records. We don't have that. Okay. So anyway.
Does it say when you delete the tuple, it pulls a null as the value? When you attribute all tuples in relation are assigned null.
Oh, this is alter. This is alter. After you define a table, if you want to modify, then you can use alter language. Alter. And for query, to retrieve a table, the subset of a table, then you can use this pattern of language. Select from where. Select from where. Okay, select from where. Select. You select, after that you list the attributes. So finally, which attribute that you want to project? Project. Okay? Select number of attributes. From student table, I want to see student name and phone number only. Then you can say select name, comma, student. From close specifies table name. I want to select this attribute from what table? From student table, or from enrollment table, or from customer table, or from patient table, from passengers table, right? All different applications. Where clause should contain a condition. Are you going to extract all the list in that table, or only the area code of phone number is 914, or something else? 713. You have 713? 718, 718? 718. This way.
Some kind of syntax in that, and you put that, you have to put like a semicolon at the end or something. I always got confused.
Which one? Which one?
The SQL query. Like
Semicolon is the very at the end.
at the end before you.
Yeah. When you complete one statement of SQL, then you need to put the semicolon. Don't forget the semicolon. This he as a predicate, so it can be disjunctive and conjunctive forms. So disjunctive normal form, DNF or CNF, if you are familiar with some of the logics, which means you may use some connector and or connector on your condition expression. For example, I want to select student list from student table where age is greater than 25 and some other conditions. And GPA is greater than 3.0. You can add more using and or operator.
Right.
Is that non-typical SQL query method?
Yeah.
Like what usually looks like their word transfer, which is like once we get need more what they already have up there in that order.
So that's a very basic form of SQL. But SQL language is I can make it very complicated with SQL. I don't know on the final exam. But if you study database books itself, then I can ask you to write a long list of SQL statements. There is one statement, but they're all connected, nested, and set operation, set minus or union, intersections, all such things, and also check the emptiness of such. For example, the student list who do not register is check the emptiness by scanning through the student's table. If that student's name doesn't appear in the enrollment table, then we can say that that student doesn't register, right? Although we do in statements here, this is SQL statements, right? Simple statements. But underlying database, that should be converted to the real programming language. For example, I have a for loop for each element in the table students. If students' age is greater than some, and add that to some others, all details of such operations should be generated. And that language is finally executed. That is how DBMX works. Okay? So it looks like simple. Simply say select from where, close. It's not going to work as is. Right? Internally, it is converted to usually C language. It's very interesting. You see Oracle, and at some points you can stop Oracle engine and see the conversion of that SQL statements, then you will see very complicated C description, C language. Of course, it's not really efficient C language. Why? Because it's an automatic generating. Automatic means it's general purpose generation. If you really do program using that SQL statements in real programming language. Then you will make more efficient programs. Internally, although you write that, internally, we do not have such course, but I've taught in other universities long time ago. That's called the database implementation. So we need to compare, okay, which one's better execution type. Although user simply told declarative SQL language, select from where, but internally it could be converted to inefficient C language, or could be converted to very, very efficient C language. Who decided that? Oracle engine itself now. The Oracle engine itself. Since 10 years ago, Oracle, before 10 years ago, Oracle, there's two types of optimization. Given SQL language, till 10 years ago, look at the language itself and algorithmic based. So by looking at the algorithm, we know which one's efficient, which one's less efficient, right? So looking at the and also look at the database size, because if you look at two tables, one table in one disk, another table in another disk, that's not the same as two tables in the same disk, because access time is not the same. Okay? So when you compare two tables, are you going to bring two tables together? Or are you going to bring one table in and the other table just swap? All different kinds. Why? Because database assumes big data, right? Cannot be loaded in your memory at once. That is a basic assumption. Not even entire table can be loaded in a memory. So you need to chop, okay, 1/3 of table in. But you have to scan all the table. How can you do it? So all kinds of complicated algorithms involved, right? So since 10 years ago, what Oracle could do, this is my previous students worked with Oracle, many of my students, when I taught theater. So I know. Now they do host-based. They have some statistical process inside. So looking at all the transactions, and then it's really customized optimization. So look at all the transactions, and they know, which queries are frequently used. If it's a general purpose optimization, then there's a theoretic, right? Okay, in theory, this algorithm is good, so we apply that algorithm all the time. But it's not the case all the time. Banking system has different transactions. Financial sector, different transactions. Airline, it's all different, right? School has different transactions, different types of query languages. So it's a cost-based. So look at the cost. Cost means nothing but space and time. So they look at the time, how quick data can be used. They also look at the table. Table grows, how fast. Okay. if it's airline, then airline database, airline, what is that, scheduling, customer database grows, changes so fast, right? What about schools? No, right? During semester, never changes. But it only changes beginning and ending. So somehow optimization is not the same. Theater ticket master database. All transient, right? You don't have to keep all the data and available upfront. Push it back, right? And if you have some statistics, then in your theater, you know, oh, we have this kind of royal customers. So every time we select those and make it one small data table and use it upfront, and all this kind of data, this kind of customers comes in our theater once a year, or like me, maybe once 3 years, 4 years. Okay, we don't need you in upfront. All like that type of things, optimization. Okay. Okay, so what we will do, skip all, and let's go to SQLite browser. Okay, so we do not have enough time. Okay, what we will do, I know you downloaded, so SQLite browser. The one that I'm not sure where I need to find out. The one that I probably here program files because I select. Okay, here DB browser for SQLite. Right, that is what you downloaded. And then there is a DB browser for SQLite. So I'm going to make double click of this. Okay, this is the one. If you look at, okay, top, let's look at a little bit, scan through, right? File, if you click this, then you have a new database, open database, remote database, then open from whatever, save from remote.
Is that like cloud?
Yeah, something like that. Yeah, import and export. That is that. And edit, view. You can see SQL log, plot, DB schema, and some others, and help. That's very on top. And one below that, there is a little bit of icons from this menu on top, because you have new database. It says create a new database file, which is in this file, right? It's a new database. So you can click this, or you can click new database there. So once you create database, then what is this? I think the database structure. This is a browse database. There's some annotation. And then more and more. So let's try to create new database. Click on it. Then it asks where I want to save. What would be the file name of the database? So I'm going to do here.
.db.
Yeah, .db. You can. I'm going to find out the directory of this course 505, and like this is to the database. No, we don't need to do that. Okay, here. So we can say college database. So it'll be college.db or SQLite. Let's say college.db. College.db. You can put college.SQLite or college.SQLite3, college.db3. I would like the SQLite 3. SQLite 3. College.SQLite 3. Save. Okay, this is very, very friendlier version of browser. So I created a database. Database is a big container. That database contains a multiple tables. So automatically this guy says, hey, you need to create table. So that is that, right? So ask me to enter table name.
When I do that, I think that the TV browser first to light only works in terminal.
You're in the different you need to go to SQLite browser.org. No, not there. Different to SQLite browser.org. Database concepts, yes. Not this engine. How can I ask you? I hope. Where are you? Did you do this? Why am I going so much? Okay. So give some ones. Let's do student, okay? So student table. And then one below, there's add field. I want you to watch in this small pop-up windows. There's a language, right? This is SQL language. Create table. When I type here student, it says in quote student open parenthesis. And then when I click this add field, so field 1, integer, I didn't do anything, but I need to do here. Field, first field, which we would say CWID, right? CWID, and CWID is usually integer, right? And then it's not primary key, it should be unique. Right? And then add another field. Another field you can say name, student name is not integer, so that you can click the right end of that integer box, then you will have text. And another field, it's not name, age is integer, fine. Another one here, no, stop here. So remove the field. Oops. Why it removes that one? Name, text. Okay. And then and when you see this, the create table, students, CWID, age, name, we don't do yet major. Okay? We'll do major after we create department. Why? Because department exists first, right? In real story, in particular college, department exists first or student exists first? Department should exist first. So we better create departments, and then we assign students to a department. We can modify it at any time, right? In real language, it is called alter, but let's make it simple here. And new table and okay, create another table. You'll click here, right above that. If you look at my mouse, then create another table. So we can say department. Okay, and add the table. We have a department name, and that should be text. And department name is unique. One unknown. What is that? It's auto increase. It's a primary key. Not null. That's fine. Not null, and it doesn't matter. If it is a primary key, it's primary key. So when I click primary key, it says primary key name. And then add. Another one is, let's say, chair. Text. This should be text also. Name text, chair text. So as I click this, then you will see the real language here, bottom. Right? It's very handy. Let's create table in quote department open parenthesis in quote name text comma chair in quote and text comma primary key and name, and at the end semicolon.
I wanted to ask you something now. The first one, what did you check? Did you check primary key for the CWID for the first one?
Yeah. Click this, therefore you have primary key.
Okay, but you also made that one unique?
You could do, but primary key is, yeah, you can do unique. Primary key by default is unique, right?
Okay.
Primary key in data types implies unique and non-null. If it is primary key, then it should be non-null. It should be unique.
What chair is text?
Why?
I mean,
I
maybe
put
the
chair.
number of the chair in the name of the chair.
Why chair? Chair is Dr. Chen, so text. Oh, you're talking about number of chairs?
Yeah,
No, it's not number of
maybe,
chairs.
Maybe the number of
Chairperson.
And then you could just go to the table and right click and you can modify it and go back to where it was.
Oh yeah.
Yeah.
That's why. For example, if I unclick primary key, wow, disappears, right? If I click primary key, fine, okay. And I'm going to modify the table.
You can right click on it. Oh, yeah.
This is department. This. Oh, where is it? Oh, here, students.
Yeah.
Create. How can I browse? Okay, browse table. Oops, no. Okay, that's fine. So name and chair. This database structure, this is one over there. Okay, database structure, create table, create index. Right. So here, and modify table. Okay, modify table. Okay, modify.
Yeah, as I was saying, you can just like,
Right.
where you were.
And then you can put here, for example, major. Major is text. Would there be any, okay, foreign key. So you can put here, okay, I can, okay, so for foreign key. Okay, rather than doing, we simply type. It's not type.
No, you can type in there, right?
That's what I thought.
No, you can type over there.
No. Oh, you mean here?
Yeah.
Type
There.
how? Which one? There should be some. Let's put here some advanced. Remove, move, build up. Can we? Oh, it's not possible. So let's put here department, open parenthesis, and department has name. See how it works. Oh, great. So foreign key of major references department name, close parenthesis, and another close parenthesis and semicolon. Let's see if it is accepted. Type OK. Great. So we have two tables, right? So what I'm going to do, let's try enter some name of, oops, why we do not have that one. Syntax major reference. Okay.
So we go
Department.
CWI.
So let's, why we do not, department, oh, department has name and chair. Oh, yeah. department, let's say math, chair, let's say Chen. Okay. And enter. And then I can say new row, insert. Oh wait, not this, not this. So we have, this is the first row, right? So we have math and Chen, and then another button here on your upper right corner of that pane. There's a new records, and then you can put here, for example, SciSec, cybersecurity, and then name, let's say Yun. Okay? That's for department and students. So new records, you can say student ID 123, 122, and then age 32, name Paul, and major. Let's say major. If I say CS, by the way, there is no CS department currently in our database, right? See what happens. Enter. Is it taken? Should not. Wow, it is taken. It's not really powerful. It's a light version. It should not.
Yeah, but no. So maybe that's considered.
No, this is a new. We need to enter this. I'm talking about the first row. Here.
What do you mean by deductive? You should be able to tell us that there's a problem.
No, not even go to a deductive database, but a typical database. If you use, say, reference department name, then it should reference, right? Somehow. Oh yeah, foreign key is not supported by SQLite. That's right. Yeah, previous version, but this is new version. Right. I'm not sure. But in theory and in real DBMS, keep in mind it has reference. Okay. But right now we do not. What about? This is the key, but I put that null, age 21, and name James, major, CSEC, enter. Oh, that is also works.
Oh, you didn't put anything? You didn't put anything?
Right, intentionally. But still accepts. So constraints is not really properly maintained.
Like,
Huh?
like,
Yeah, it is a light.
What is this data mismatch? Data type mismatch.
Oh, is there? Where? Do you have?
I guess it's...
In the case? Right. Yeah, But anyway, in this way, you can create more and more table. Let's do select statements. Where is new open data? Okay, SQL statements. I want to do select star from student semicolon, enter. Execute. Then I have, see, I entered the two rows, right? 122, 32, Paul, CS, and 21, James, CSEC, according to this. If you put more, for example, wear clothes.
I
where age is greater than 30, and then execute, then only poll, right? If you do not have this condition and execute, then all.
Select student where what? Where
Age, whatever. You can use something else. Where major equals CS or CSEC. Where major equals CSEC. No search column selected from. No, that's not a good word. Oh, because I need to put here quote. Yeah, quote, then I have six sections only. Right? Major equals import CSEC. CSEC is a value. Major is something defined in the table.
is there any way you can get like generated data? You just put it in there, so then you can, if you were to then show these topics to somebody else and show them how to like modify the data, or like if you can show how there's like there's a bunch, there's like these are the integer, the text.
Exactly.
You know,
That is possible. One time earlier days when we, for example, the following story is very sophisticated technology. When I taught Android apps development, Android. So from Android apps, we put there some database modification tools so that students, whoever, click, I want to change some table definition structures. So from there can be changed also. Anything that you want, possible. Not necessarily you come to database and change it manually, but you can provide some application programs so that it can also run. All right. Any question? We will do a little bit more using this SQL-like database next class. And I don't think we will do. Yeah, we'll do as much as we can, right? Because we have only one class left. I'm thinking of, you need more practice using SQL-like GUI-based operations. That way you may feel more concept, using the concept of database. So that's what we'll do. And I need to choose either additional command line database access or a little bit of Python coding based database access. Yeah, we also need to review.
Yeah,
Then we do not have enough time. So we'll optimize, okay? Whatever we want.
So we're gonna have to like look, like select where from where.
Yeah. Yeah, bring some good good ideas to express, then we can try together. Okay? So have a good weekend.
So we're gonna make more like